are you talking about?
The call.
Call, C-A-L-L? Where?
In the corner.
C-A-L-L.
Yes.
Oh, that's what I'm recording.
Oh.
It's this, yeah. You've never seen, I do this almost every class. You've never seen this pop up? Yeah, it's just, I use Teams. Like you remember when you had to use Teams when you're at home and stuff? I still use that, but I only use it to record. It's got a recorder in it. So it records the screen, everything. So again, the distance, when it says the distance between two lines, 2 points, we're really only going to probably do a point and a line. The distance is the perpendicular distance to that straight line. Always, 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 always. That's the shortest distance between any like line and a point or even another line is always the perpendicular distance. All right, so I don't think there's anything else really to go over. We're just going to do some. Oh, you will see probably or possibly some proof stuff when you practice this in here. We are done with proofs. You're taking a quiz today on proofs. Even if we see some proofs, I'm not going to say I won't maybe explain it to you really quickly, but you're not going to have to worry about doing any more proof quizzes. We're done with that. A lot of it's logic. Quiz today on proofs. Yeah, it's just 3 questions. You are going to, again, you'll be choosing from a list of options and filling out the different reasons on the proof. And you only, I think on one of them, you only have to do 2. On the other ones, you have to do either 3 or 4, I think. All right, so let's go ahead and go to a problem. There we go. So turn to page 210. So here's what I want you to do. You should be able to do these first 2 steps. So I'm going to tell you the steps. It wants you to find the distance between this point and this line. So I'm going to give you the first 2 things you should be able to do right now. Step 1, you need to find the slope of the line. Step 2, turn that into the perpendicular slope. Actually, we'll say find. Perpendicular slope. Then by that time, I'll probably be doing it and I'll do the next few steps for you. On the next problem, you'll have to do all the steps. So for right now, so you have it in your book. If you want to look up here, if you don't have the pages, there's no reason for anybody to just be sitting there. There's the figure in a close-up version. So you're finding the slope of this line. There's a couple ways to do that. If you already have a graph, there's one that's pretty fast. And then once you find that slope, I just showed you earlier how to turn that into the perpendicular slope, which you have to do to change the slope into its perpendicular version. I'll give you shouldn't take longer than 2 minutes. I'll give you 3. You can go ahead, Jeremiah. And my tree's falling out. Jeremiah! 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 Tree's falling out of the cat. Yeah. Oh no, I'm still trying to keep it. He's not back in 5 minutes. I just keep all my passes and everything that I see them. Can't you tell how boring? Still got a couple of minutes. Ready, done already?
Oh, wait.
I mean, they're telling you what to do right there. They literally work the whole thing out for you. All you gotta do is fill out the blanks on the left. It's the final, like, 2 blanks and all you gotta do. Oh, this is all you're having to do, really, right? Well, that's, first you figure out the slope, then you turn it into perpendicular vertical. They tell you right there, it tells you right there, it's got the formula, and it's already plugged the numbers in and everything, you just have to do the math. Pretty much don't have to do anything with it. The slope is already pretty much done for you. Look at it. You have to know how to turn it into the perpendicular version, but you got all the numbers plugged in already for you. It looks like on the slope part. I'm going to show you a different way that I would use slope. All right. So if I have a graph, I would never use that formula. I don't know why you would use that formula. That formula to me takes way longer. If I only had 2 ordered pairs, like if I just had, like there's no graph and all they gave me was these 2 things right here, then I probably would wind up using formula. But if I've already got a graph, I would use rise over run. I mean, that's the slope formula. It's way faster. I would say, okay, well, I just need to figure out from going from this point to this point, what's my rise and my run? I always do run first. So I would go 1, 2, 3, 4, and that's positive 4 because I went right. Up 2 is positive 2. Again, if you understand that a line that slopes up from left to right is positive, you don't even have to worry about whether it's a positive 4 and a positive 2 or negative or whatever. You just know you need a positive slope because the line is going up from left to right. So I normally don't even write the positive and negative in. But if you don't understand what I was saying, you need to understand which directions are positive and negative. We'll do a negative one in a second. So this is my run number down here, my rise number there. The formula is rise over run. And I'm doing way more than you would really need to do, just to show you the steps. So that's how I would do it. I would do rise over run every single time they gave me a graph. I mean, the only time that could get tricky is if they really gave you a line where it was hard to tell when you were going through like the specific corners of squares, so you couldn't tell what your how far over like you were going or something. I don't know. I don't know of any situation where it's not going to be easier to do that. You do need to know how to simplify that. 2/4 is the same thing as 1/2. So you divide the top by 2 and the bottom by 2. That gets you to 1/2. So that is step 1. We've now figured out the slope. Again, they did most of the work. They used the formula. They said this is x1, y1, x2, y2. And so to explain what they did, they said 4 subtract 2 divided by 5 subtract 1 gives you the same answer. So that's how they did it. And we're going to use probably that slope for some other problems. Maybe not today, but now I need to do step 2, which is make that into the perpendicular version, perpendicular slope. Who am I going to call? I'm going to call be mindful. You know how to, and if you don't know how, that's fine. I'm just taking a gauge of where we're at right now. You know how to do that. Diego, you know how to do it. Don't tell me, just say, do you just a yes or no right now? You know how to change the 1/2 into, or like you think you know how to change it into the perpendicular version. Not sure? Do you know how to do that? Maybe, and I'm really just taking a gauge. I don't care if you do or not right now. But I hope you do. Don't know. Henry, do you know how to change that 1/2 into the perpendicular version? What would the slope of a perpendicular line be to that line if that line is a 1/2? Yes or no? Right. Either of you guys know how to do it. So a perpendicular line means we're going to create a 90-degree angle. So hopefully you know that part. It's just a rule. Like there's no figuring anything out. This is just how you do it. So just write this down. You have to memorize it. You have to memorize it. I take, so again, to change whatever you got to write, to change a slope into the perpendicular slope. That's what I would write. This is the slope of line L. That line right there, that blue line has a slope of 1/2. If I want to create a line, not yet. Are you asking me to go to the bathroom? Just let me finish this. If I want to create a line perpendicular to that, it's going to have to come through something like that and form a 90-degree angle. That's our goal. We want a line that comes down and intersects at a 90-degree angle. That's what perpendicular means, 90-degree angle. Again, it's not a logic thing. It's just, you just have to know how to do it. You take the slope of this line that you already have. So we have a slope of 1/2, and then we flip it upside down. And we flip the sign. So if this is a positive slope, this has to be a negative slope. I mean, there is some logic behind it, but I think for most of you, it's easier just to remember you flip it upside down and you flip the sign. That is a perpendicular slope. Always, no exceptions. Like if you have one slope and you do what I just did, the other slope will be perpendicular. If my slope would have been 2/3, I'd flip it to 3/2 and I'd make it negative. You're always going to have one of them be positive and one of them be negative. You can never have two positive slopes or two negatives that are perpendicular to each other. One has to be positive, one has to be negative. All right. Now that we've done this part, I'm going to do the rest of it for you. So again, this was step 1. Step 2 was just to flip it. I'm going to still leave it in a fraction form. Technically, that's just -2, but we still need a rise and a run for the next part. So I'm going to leave it as that. So here's where it gets a little, I'm doing this differently than the book does. The way I do it won't work every time. But to do the version that works every time is really complex. You think this is complex? You should see what we might still do it next week, but it is very, very complex. Okay, we need to keep that. All right, so here's what we're going to do now. Oh, so our goal is we're trying to find a point, and there's only one. Somewhere on this line, there's a point that is like the perpendicular line we're creating. Like you hopefully can tell, it's not going to be over here. Hopefully you can see that's not perpendicular. So that's not where it's going to be. It's not going to be over here either. Hopefully you can see that angle there is not a 90-degree angle. It's going to be somewhere like in here. Because if I drew that, it would look like it's a right angle. Like that's what you're trying to create, is a right angle. You're trying to draw a line through this point here into this line that looks like it's 90 degrees. I'll give you a hint. If there's ever somewhere where it looks like it's right on the corner of squares, and if you drew it to that and it looks like it's kind of perpendicular, probably the right one. That's your first hint. Sometimes the obvious is the correct answer. So to me, that looks like that's probably going to be the spot. But we're going to figure it out just to make sure. I know what my slope has to be for this new line I'm drawing. This is the perpendicular line and needs to have that slope. I'm just going to take this point and I'm going to use those numbers to see where I hit the line. And hopefully I land right on a spot that's easy to come up with the X and the Y. Does anybody know how I do this next part? So I want to use rise over run. So I'm creating a line. I have a point that I'm starting from. How do I create a point that has a -2 slope? I'm sorry, how do I create a line that has a -2 slope? Didn't ask this question. I have a feeling nobody knew it. Talk about that. You've graphed before where you created a line from y equals mx plus b. You said, okay, well, if this is the formula, what's the slope in that formula? M is the slope. So you said, okay, I know that's the slope. What's that? M is the slope. What's the b? Y-intercept. So what you did is you put a point. Actually, I'll do one really quickly. Here, we'll do this. We'll say y equals -3x plus 4. I'm just going to graph this really quickly to remind you what you did. You said, okay, well, I know that's the y-intercept. So you just put a point on 4. Oh, good. So if you want to go ahead, you're missing this, but you'll have to catch up when you get back to them. You then said, well, I know my slope is -3, so you made that into a fraction. Then you had a rise and a run number. And you said, okay, well, my run number is +1. So I go right 1. My rise number is -3, so a negative rise means go down. Kind of messed that up. Should have been a larger middle hop, but I'd still land in the same spot. And you said there, those are my 2 points. And then you just drew a line through them. You said, all right, well, if that's my point, that's that line. You did that algebra, you did that in pre-algebra, you should have done that a lot. We're doing the same thing, only we're not starting at the y-intercept. Instead of starting at this y-intercept number, we're just starting at the point that they gave us, and we're just going to use these 2 numbers. I always make the top number negative if there's a negative in front of the fraction. So I'm going to say my run is +1. My rise is -2. I'm going to hop 1 for my run. That was positive. Right is positive. Rise of -2 is down 2. So I'm there. Now the thing is, I'm going to keep doing that pattern. I'm not just going to draw a line through them. I'm going to do that pattern again. I'm going to go right 1 and then down 2. Sure enough, I land right on that spot that I was thinking I would land on. It is very obvious that that spot is an x of 3 and a y of 3. We're not going to, not today at least, and we may not ever do it. We're not going to do the more complex version. What if we didn't land on that spot? What if we would have landed right here or crossed through right here? That is much more complex. The 2 examples they give you in the book, this works. So we're sticking with this for right now. There are some practice problems you'll do next week, and we'll see if those are more difficult. If they are, we may do the other version. So now this is our line. This is our line that is perpendicular. So now we have that line. We need to measure distance by doing the distance formula. So we take these 2 numbers, and the distance formula is in the book for you there. It's step 4. I've actually already done it out for you, but try to do it on your own. And you've done distance before. Remember, we did distance when we did points on a graph. What's the distance between 2 points on a graph? You also did perimeter of a shape. That was, you had to do distance when you did perimeter of a shape, the distance between 2 points. I want you to try to do the distance formula and find the distance between those 2 points. If you get stuck, it's pretty much done for you, but try to do it on your own by just looking at the formula. If you don't have the formula, I'll just tell you this is it. That's the formula if you can't see it. So you just have to label the points correctly, just like we do everything else. One's x1, y1, one is x2, y2. Plug them in the right spot, and take the square root. I'll give you a couple minutes to do that. You get done before the 2 minutes, just go ahead and put your phone down. Understand what this is gonna mean to your senior year. Not gonna be fun.
Have to separate it like backgrounds. I think I can set up a positive. Plus set down positive. Negative.
Oh, no. So you're thinking of quadratic equation.
Yeah. So,
Yeah, this is just your, now you might get negative numbers inside the parentheses, like this could be a negative number and that could be negative. But remember, when you square a negative number, it becomes positive. -4 squared is positive 16. Any negative number squared is a positive number. So that kind of goes away, so you don't have to worry about that. All right, so 15 seconds. All right, so if you plug in the numbers, I'll label them and everything, but I won't take off if you don't label them. Although I will say it's a good idea to do it. Ultimately, people make mistakes when they don't. So there's how I would label it. Doesn't matter which point you consider to be point 1 and point 2. I could have made this x2, y2, this x1, y1. So now I'm going to plug them in. I guess I'll do it over here. X2 subtract x1 squared plus y2 subtract y1 squared. I'm going to wind up taking the square root of that, but I'll do that on the next step. So 3 subtract 1 is 2 squared plus -4 squared. I'm going to wind up taking the square root. So this would be 4 plus 16 is all in your book, I think. So the answer is the square root of 20. So it comes out to be probably like 4 point, almost 4.5, maybe something like that. You took the square root of it. First. Did you take the path out? Did you, Jeremiah? You didn't take a path. I think I grabbed him. I was trying to get you to come back for it. Maybe not. Hmm? Oh, that's right. Somebody's out. So wait till he gets back. I was gonna say, no, I just know the path. So the answer is square root of 20, which probably is about 4.5, something like that. Maybe a little bit less than that. Oh my goodness gracious.
I was doing something.
So where's your pass? All right, so go to, I think it's at the top of Yeah, I think it's at the top of 211, right below, I think, step 4, it says check. So do that problem that says check. At the top of 211, there's a little thing that says check. Same exact thing we just did. Try to duplicate those same steps. Find the slope of the line, change that to the perpendicular slope. So you just flip it upside down and change the sign, the positive or negative sign. Then you got to try to work your way back from the point down to the line using that perpendicular slope. And if you do that, and I'll just tell you right now, it will land right on a point that's easy to tell what the X and the Y are. Then you can do the distance formula on the 2 points that you'll have on the line. They're here. So you want to try to work your way from this back down to the line. If you kind of try to figure out a perpendicular line somewhere in there, that's not even exactly perpendicular, so that doesn't look like it would work. Kind of like I said. Boy, that looks pretty perpendicular, and it also happens to fall right on an X and a Y, so my guess is you're probably going to wind up right there. But go through all the steps of step 1 and step 2, and then see if step 3 gets you to that point right there. And if it does, you would use this point here and that point there and do the distance. The distance between that point and that point. So despite what you may think, no phones right now, so I have to do this for anybody else. You should be to the point where you're working your way back to the line. You should have done the slope by now. You should have then doesn't take any time at all to flip it into the perpendicular slope. We're on page 211. 9 to 10. So if you want to follow along, this will be your lesson when I work this. When you get to the point where you need to do a square root on those calculators, you have to do the square root button first, which is, I think you hit the second function. Second function, yeah, second function, and then the button that has actually x squared on it. If you look above the x squared, there's a little square root thing. So second function. Then hit the x squared button because above that button is the square root symbol. And then you put your number in and hit enter after that, or equals. Give you another minute to wrap that up. If you didn't quite finish, as long as you were making progress, but give you time to study before the quiz today. So I'm just looking. You should at least have steps 1 and 2. You should know how to do a slope and how to change that to the. All right, so step 1, slope. Again, if I've got a graph, I'm going to use rise over run. Because though, I think a lot of you wind up using the formula. In this one, I'm going to do the formula. So x1, y1, x2, y2. Formula is this. So I'm talking about the slope formula, by the way. So here's your slope formula. So now I just plug the numbers in. Once you've labeled them, it's just a matter of putting them in the right spot. -6 is my y2. My y1 is 3. My x2 is 4. My x1 is where? -5. Do this in your calculator. A lot of kids tried to do it in their head and messed it up. So if you do it in the calculator, you get -9 over +9. You do need to understand that's -1. Using -9 over 9 is not going to work to do this next step that we're going to do. So that would be a slope of -1, or we really need to keep it as a fraction because we're going to do, we have to flip it into the perpendicular slope. So if my numbers are the same, when I flip it upside down, it's still going to be the same numbers. The only difference then is I change the negative to a positive. So my perpendicular slope, so step 2 is +1. +1 over +1. We have to have both numbers. So now I'm going to go from this point and I want to come back down to this line using that perpendicular slope. So that's the perpendicular slope. And I'm trying to create a line that is perpendicular to this line, but goes through that point. Well, if I start from this point and I just follow the rise and the run, That will give me the line, but there's one, not until I finish this. There's one, actually, he's still not back anyway, so as soon as I'm done, I'll let you go, even if he's not back. Who knows when he's coming back? Should have started tracking him. He's never in class. He's been gone for probably at least 6 minutes, so. So now, if I just do the rise and the run, you'll notice both of them are positive. So that gets me going this way. +1, +1, +1, +1. I'm going the wrong way. I'm not going to my line. You have two, hey, speed it up. You have two, oh, actually, I got one waiting before you, I forgot. Not yet. So, wait, did you get all this done? Then you. All right, so you could just draw a line through that. Take a ruler and just draw a line and see where it hits the other line. That's not always perfect though, especially if you don't have a graph. Like if you created your own graph, that may not work. If this happens and you're going the wrong direction, and this is anytime you're graphing, like when you graph, anytime you're going the wrong direction, change both directions. So instead of going right one and up one, go left one and down one. Left one, down one. We do that, we land exactly on that spot that I was talking about before that looked like it was probably the correct spot. That is the point on this line that will create a perpendicular line. That -2, 0. So -2, 0 creates a perpendicular line with this point 2, 4, the point Q. So your last step then, now that you know your second point to use, we need the distance between those 2 points. That's where you come back and use that distance formula. So we do all of that. Again, we're using different points now. Don't use the same original points. That was for slope. So now I'm using 2, 4 and -2, 0. If you, actually, I guess I'm recording. I need to go ahead and do this. So if I plug them in, x1, y1, x2, y2, I'm going to plug them in like right below the formula. So my x2 is -2. Subtract my x1 is 2. I'm going to square that. Plus y2 is 0. Subtract y1, and I'm going to square that. So depending on how far you got on this, we're going to do more of this next week. That's why I'm just kind of finishing it off. Depending on how far you got, you might be in pretty good shape if you have all of this stuff down. If not, you got to practice these last 2 steps a lot next week. So you wind up getting the square root of 16 plus 16, I believe. Square root of 32, so that comes out to be like 6.6 or something like that, I think. 6.6, 6.7. So again, I'll decide, I'll look at the practice problem sum, and if they all work out nice and evenly to where you just land on a point where it's easy to tell the X and the Y on the line, I probably won't teach you the other version because the other version is pretty complex to be able to figure that point out if you don't land right on it. If any of them don't land, or if a lot of them don't land on it, we may have to learn the other version. Depending on the spots you use. Well, on this particular one, if you notice, they count by 2s. So let me address that real quick. They count by 2s, which makes it a little tricky. You can use any points you want. Just because they gave you these 2 points doesn't mean you have to use those 2. You could have gone from here to here, because that's pretty clearly right on the line. You could have said down 2, over 2. I mean, really, the slope's always going to work out. 2 and 2, technically that would be negative. If you notice they count by 4s, it would just be -4, +4. Slope's pretty easy to do when you do rise and run. That's why I like that version better. As long as you got -1, then you're good. Any other questions before I let you start practicing? All right, so we're gonna start the quiz in 20 minutes. Yeah, 20 minutes. So you got 20 minutes to just, I mean, you can't learn it in 20 minutes, but you want to look some stuff over, refresh your memory on some of the more common reasons that we used. Postulates, definitions, theorems, all that kind of stuff. Set the timer. Bless you.